there's really two kind of problems in the chapter, remember. The first kind is single sum problems, right? And for that, we go to table 1 and table 2 in the back of the chapter. And then we have annuity problems, which we go to either table 3, 4, or 5, okay? So y'all remember we did the single sum problems last time. And the way the single sum problems work is that we have a period of time, right? And we're either looking for the present value or the future value. And there might be a period of years in between. So like, if the present value is this number, what is the future value in this period of years at this certain interest rate? Because remember, we had, what were our 4 variables that we might have in single sum problems? Present value, future value, interest rate, and number of periods, right? So those are our 4 variables, and one of those will be missing. So we'll plug in whatever 3 variables the problem gives us, and then we'll be looking for that 4th thing, which is our question mark thing, right? And we're either going to set the problem up. The problem is either going to be set up like this: present value equals future value times some factor, right? This is if present value is the question mark. And in that case, we would use table 2, right? Or we would set the problem up where future value equals the present value times some factor, in which case future value is our question mark, so we would use table 1, right? So that's pretty straightforward. Wouldn't y'all agree? Then if we don't know the N or the I, what do we do in those situations? Right, so how do you set the problem up? Which one of these 2 ways? Either one. Either one, and then you just, one of these is going to be a question mark, right? Either the N or the I, and then you'll either have to divide, or it's going to be like an algebra problem. And the way that we always picked when we did it was future value, right? That's the way that we did it every time. And in that case, if we pick the future value, then we would look on the table 1, right? And we would end up dividing, okay? All right. I think that's probably the easier way to pick, to be honest. So I usually pick that way. Okay, so today we're going to do annuity problems. And the way those problems are, the single sum problems are set up because no matter how many periods in here, we only have this one single sum, either the future value or the present value, right? So in an annuity problem, annuities are equal amounts over multiple periods. Okay, so an annuity is equal amounts over multiple periods, okay? So the way that looks is we have these multiple periods here, and in each period we have an equal amount. And that amount is called the rent. Okay? So we have a rent in each period that's an equal amount. So we don't have these rents up here in single sum problems. Okay? So we have a rent each period. Now, this that I've drawn a picture of is an ordinary annuity. How do we know that this is an ordinary annuity? That's this, ordinary annuity, instead of an annuity due. That's this one, annuity due. What's the difference between an ordinary annuity and an annuity due? No idea, right? Okay, so in an ordinary annuity, we assume that the rent occurs at the end of the period. Okay, so in the end of this period, there's the rent. Then of this period, there's the rent. In an annuity due, Let's just move this down a little bit. Okay. In an annuity due, the rent occurs at the beginning of the period also. Okay, see the difference? The rent occurs at the beginning of the period also. Annuity due. Okay? So in this case, this would be a present value of an ordinary annuity. In this case, this would be present value of annuity due. That's the only difference. Annuity due, ordinary annuity. There's a rent at the beginning of the period in the annuity due. Okay? So this would be the future value of an ordinary annuity and the future value of an annuity due. Okay, so now let's summarize here which table we look at in all of these situations. If we're looking for this present value, what table do we look on? 2. If we're looking for this, what table do we look on? Future value. 1. If we're looking for present value of ordinary annuity, we look on present value. Yeah, they're not in the right order, right? And then this one we look on 3, right? Okay. Now, this one, present value of an annuity due, we look on 5. What table do we look on for this one? None. We don't have a table, right? So that's one that we're going to have to figure out what to do. We're going to have to figure out what to do on this one, okay? The rest of these, we all have a table, and now we have a picture. So I think this picture helps you see, if you can visualize what the problem is asking, the picture kind of helps you see what the problem's asking, okay? All right. Now, in this book, in this chapter, you might have noticed I'm not really going over the PowerPoints. This chapter is, it doesn't read like the rest of the chapters, per se. There's not a lot of words. It's more working through problems. Matter of fact, this chapter is not really like the rest of the chapters in a lot of ways. So the things that I'll tell you about this chapter is, really, there's 7 kinds of problems you have to know. These 6 right here, plus bonds, okay? So you have to know how to do these 6 problems plus a bond problem. And we're going to go over all of that today. And when you get that straight, this chapter is going to be pretty straightforward. So as long as you do these exercises over and over again and you know how to do them, you're pretty much going to know this chapter cold. And I mean, really, with a lot of practice, you could do very well on this chapter, okay? So I would look through the chapter for the concepts, but there's fewer concepts in this chapter, so it's mostly problems, okay? And so it's very repetitive kind of problems asked in a few different ways. So and you've got a lot of solutions, to things in the back of the, you've got solutions to the exercise so you can work problems over and over again and get practice, okay? So how do we set up these problems right here? We set these up the same way so that we have present value of an ordinary annuity. Well, no, not the same way, a little bit different. So let me go into that. Remember we had present value, future value, interest, and N. On these problems, on the annuity problems, we have a different set of things. We still have N and I, but we also have this rent. This is one of our variables, okay? So we have the rent, and then we have either a present value or a future value of an annuity problem. We have, one of these. We have one of these, So if we're doing the present value of an ordinary annuity, the present value of an ordinary annuity is equal to the rent times this factor that we find on table 4. Okay, so see how you set that up? It's just a little bit different. Or if we're looking for the future value of an ordinary annuity, that's equal to the rent times a factor that we find on table 3. Yeah, that's the generic term. It means the amount of the payment. It doesn't really necessarily mean rent like we're paying, like paying rent to a house, but it means the amount of the standard payment. So the payment's an equal amount every time, and they just call it rent, I guess, because that, in economics, a lot of times that kind of means an equal amount, I guess. I don't know why they call it rent. So you could just say payment right there. It's the amount of the payment. Okay. And then if we have the present value of an annuity due, that's equal to the rent times the factor that we find on table 5. Okay, so now let's just go ahead and say, what do we do with the future value of an annuity due? What do we do with the future value of an annuity due? We don't have a table. And it is similar to the future value of an ordinary annuity in that we still use these same things here, and we go look on table 3, but we multiply that whole thing times 1 plus the interest rate. Okay? We do this whole thing that we did on an ordinary annuity, and then we're going to multiply our answer times 1 plus the interest rate. Like if our interest rate is 5%, it would be 1.05. Because see, we're just adding, what are we doing? We're just adding we're accruing interest for this one other period here that, see this one period from the beginning. We're getting that one interest on that one period in there, okay? All right, so that kind of sets up all the problems. And now we should be able to do everything from right here. Okay, so what we're going to do is start with number 5. This is on page 323. We're going to start with brief exercise 5. Okay, so in brief exercise 5, we're going to do the same thing where you guys are helping me for every problem, okay? So Sally, somebody, will invest $8,000 a year for 20 years in a fund that will earn 12% annual interest. If the first payment occurs today, what amount will be in the fund in 20 years? You want to move back there to that? You can move back there if you want to. Okay. All right. So who wants to help me on this one? Sally will invest $8,000 a year. What is that? What do we call that? The rent. Okay. That's the payment that occurs every year, right? For 20 years, that's the N. In a fund that earns 12%, that's the I. If the first payment occurs today, we're going to skip that one. We're skipping that one right now. If the first payment occurs at year end, what amount will be in the fund in 20 years? They want to know what amount will be in the fund in 20 years. What's that? Future value, ordinary annuity, right? Okay, so this is what our question mark is. We skipped down. Now we're answering the last part of the problem. If the first payment occurs at year end, what amount will be? So this, an ordinary annuity, the payment occurs at the end of the year, right? So we're doing the future value of an ordinary annuity. Now let me just mention that in both of these problems, it's assumed that things happen at I mean, end of the year is the ordinary thing, okay? Let's just think about it that way. All right, so now how do we set up this problem? Which one of these do we want to do? What's on the left? What's on the left? Which one of these four? Ordinary annuity, right. Okay, so I'm just going to erase these guys. Okay, so we're doing the future value of an ordinary annuity, and so we're just going to say that the future value of an ordinary annuity equals the rent of $8,000 times this factor where N equals 20 and I equals 12%, and we're going to look on table 3, right? So we look on table 3, and what kind of factor do we get? $72.05. Yeah, 244, right? 244. Yeah, we just take it all the way out on these tables. And okay, so my idea is to take it all the way out on the tables and round your final number, okay? I'm happy with rounding your final number to an even dollar, okay? But it's best not to round the table number, okay? All right, so when you multiply that out, you get 576, 420, right? Okay, so let's think about that. Let's just think and see if that makes sense. Does that make sense to you guys? We put $8,000 a year somewhere where it earned interest for 20 years. How much money did we put in? $8,000 for 20 years. Avery? You got it? 160,000. So 8,000 times 20, 8,000 times 20 equals 160,000. What happened here? How did we get up to 576,000? Interest and compounding, the interest compounding, you know? Doesn't that seem magical? Like you could be, you're almost a millionaire here, and you put in 8,000 a year, right? So these problems, you know, the interest compounds really fast. And the one thing that happened is our interest rate is 12%. You know, so really on $8,000, what's 12% of $8,000 is really almost $1,000, right? So it's going to build up pretty fast, and then the next year it's going to be earning interest on $9,000, and then the next year on $10,000 or $11,000. So it's just going to build up pretty quick. Do you see what I mean? Okay. All right. So this is the future value of an ordinary annuity. What is this telling us? This is telling us what will be in our bank at the end of the period. What's the total amount in our bank at the end of the period? Okay, so the next problem, well, the one we skipped really, is if the first payment in the fund occurs today, what will the amount be in 20 years? So what kind of problem do we have now if the first payment occurs today? Annuity due. We're still asking what will the amount be in 20 years? That's still our question. What will the amount be in 20 years? But it's an annuity due instead because the first payment occurs today, okay? So it's the future value of an annuity due. See, the only thing that was changed between this problem that we had and this one is that there was a payment today. They're still asking the same question, what will be in the fund at the end? They're asking, instead of that question, they're asking this question, right? Okay, so future value of an annuity due, we're going to work it the same way where we multiply our rent times a factor, but we're going to look instead on table, oops. Oh, wait, what do? We don't have a table, right? So what do? Yeah, we look on table 3 and then do what? 1 plus the interest rate. Okay, so we look up 8,000, 20, 12, all of this, same thing we did, times 1.12, right? So really we take our 576,420 number that we got up here and just multiply it times 1.12. Do you see how we got 1 plus the interest rate? Y'all are clear on that? Okay, so we multiply that times 1.12. What do we get there? Brett, what you have? 645.59. Okay. Okay. So, yeah. So that's how we do future value of an annuity due. So future value of an annuity due is equal to the future value of an ordinary annuity times 1 plus the interest rate, right? If we want to just add that one down at the end, that's how we would do it, okay? Does that make sense? Okay. Or you can just take it on face value even, right? All right, so now we're going to look at number 6. Okay, number 6, Steve needs $250,000 in 10 years. How much must he invest at the end of each year at 11% to meet his needs? Okay, now maybe it helps to do these on a timeline. You know, maybe in all of these problems, it would help to do these on a timeline. So if we were to do this with a timeline, Steve needs $250,000 in 10 years. Where would we put the $250,000? Angela, you want to be my person? He needs $250,000 in 10 years. Where do we? Yeah, that's in the end. This $250,000 is what he wants at the end. Okay, so we're going to say that's the, that's going to be a future value of something. Okay, and there's going to be 10 years. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and it says, okay, so 10 years. Our N, is that right? Our N is 10. Okay. How much must he invest at the end of each year? What is that? What are they asking? How much must he invest at the end of each year? Oh, the percent interest is 11%. What is that? That's our, okay, so this is 11%. All right. And which one do we have? You said it was a future value. Is it an ordinary annuity or an annuity due? He's investing at the end of the year. This one is an ordinary annuity. This one is annuity due. Ordinary, this is ordinary. This is annuity due. So which one do we have? This one is at the end of the year. This one is at the beginning of the year. Ordinary annuity. Okay, so we have a future value of ordinary annuity, $250,000. What are we missing? Rent. Okay, rent is our question mark. Let's look and see how they ask that. How much must he invest at the end of each year? That's our rent. Okay? All right. Okay, so how do we set this up? We have, this is the same kind of problem, future value of ordinary annuity, right? So I'm just going to Get rid of all this. And we can plug it in just like that, right? So what we're looking for is our R, right? So all we have to do is fill in these things, right? What goes on the left here? 250,000. And then what goes right here? 10, 11%. Table 3. You want to get me the number on table 3? Now this is where you can get messed up. Now, a lot of people say, oh, I'm going to skip this step. I'm not going to put what table I look in. And then they just pick a table in the back and pick a number and put it down. You know, you're going to have like a 1 in 5 chance if you just try. In other words, I think it's a good, helpful thing to decide beforehand what table to look at. All right, so what do you have? 72201 times our R equals 250,000. Okay, so now what do we do?
I would say divide the 16.2201 on the future base.
Okay, so we're just going to divide each side by 16.2201. Right? So we divide each side by that, and we're left with R equals, this crosses out, right? So we're left with R equals this. So what do we have there? $14,950. So what is that telling us? Have to put that amount in every year, and then at the end of the time you're going to have 250,000. So if you put like basically 15,000 in a year for 10 years, how much have you put in? 150,000, right? 15,000 times 10 equals 150,000. But instead of having 150,000, you have 250,000 because the interest adds on there. A lot of interest, right? Okay, well that's interesting. All right, so now we've done two kind of future value problems. We've done, well, three kinds. We've done where we've done a future value of an ordinary annuity, a future value of an annuity due, and a place where we're looking for the rent, right? Okay, so now we're going to do number 9. Number 9. Morgan Freeman is investing $16,000 at the end of each year in a fund that earns 10%. In how many years will the fund be $100,000? Okay, so who wants to tell me this one? I need a volunteer. Brett? 16,380. Okay.
The interest is
10%.
10%. You don't know the number of years.
Number of years is our question mark.
Future value of annuity.
Yeah, the 100,000 is the future value, and how many years will the fund be 100,000? They're asking in a bunch of years it's going to be 100,000, so that's definitely a future value. What kind of annuity?
Ordinary.
Ordinary, because they said at the end of the year. So we're doing a future value of an ordinary annuity, and that's 100,000. Okay, so this is the same kind of problem, right? Same kind of problem. So our future value is 100,000. Our rent is 16,380. Our N is the question mark. I is 10%. We're going to look on table 3, right? Okay. So now what do we do? What's our deal? How do we solve this, Brett? 16,380. And this one crosses out. And on this side, we have some factor, right? What's this?
6.10500.
Okay. All right, so is that our answer then? No. What do we do?
Find that on the table.
Okay, so we go to table 3, and we look under 10% until we get to 6.105.
That's at 5 years.
5 years. So n equals 5. Okay? Are y'all straight on how to do that then? So now we've done 4 kind of future value problems. Because now we know how to solve these where we get this factor and look on the table. Okay? So now we're going to look at number 10. All right. All right, Henry Quincy wants to withdraw $30,000 each year for 10 years from a fund that earns 8%. How much must he invest today if the first withdrawal is at year end? Okay, so now, Kyle, are you doing this one?
I'll try.
Okay. We're doing number 10. Oh yeah, so you missed last time where we did the whole present value, future value thing. So you're like playing catch up, but you're doing it. You got it right.
Yeah.
Okay. Okay. All right. So he wants to withdraw $30,000 at the end of each year. What do we call that? The $30,000 every year. Something that's happening every year.
The rent.
The rent. Okay. All right. And then he's doing it for 10 years. What do we call that?
The number.
Okay. N. Okay. So the N represents the number of years, okay, or the number of periods, really. It's not always years, it's periods, okay? From a fund that earns 8%, that's our interest rate. And what do they want to know? How much must he invest today? Present value. Now, which one do we have? Present value of an ordinary annuity or annuity due? And what does that depend on? How much must he invest today if the first withdrawal is at year end? Year end. Looking up here where we've got the answer.
Present value of ordinary.
Right, okay. Present value of an ordinary annuity, that's our question mark, right? Okay, so the way that we set up the problem then is we put present value of an ordinary annuity on the left, and we substitute everything in our formula. And we would be looking on table what? Okay. So we're just going to plug the rent in, the N, and the I, and look on table 4 and get a factor. What do we do?
I think it's the future value of annuity.
Okay, let's read the problem again. 10. He wants to withdraw $300,000 each year for 10 years from a fund that earns 8% interest. How much must he invest today? If the first withdrawal is at year end.
So that's rent put in at the beginning of the year.
At the end of each, it says if the first withdrawal is at the year end. So okay, so let's look at our picture. This is our picture of a present value of an ordinary annuity. He's taken out, he wants to withdraw $30,000 a year, every year, like this. what he's going to do is he's going to withdraw this fund down to zero in 10 years. He's going to have a sum in the bank that we don't know what it is, and he's going to take out $30,000 every year down to zero. They don't really say it like that, do they? They don't give us the future value, do they? Because what they're saying is he wants to withdraw it all the way down to zero. Like, let's pretend that he's retiring, and he wants a certain amount of money in the fund to last him all the way through retirement, and he thinks he wants to withdraw $30,000 a year. Do you see what I mean? So what he wants to know, and I see what, okay, yeah, you're thinking through the problem, but look at the exact question. How much must he invest today? Today is present or future? Present. That's the question, the today part. Okay? You know, there are other questions kind of similar to this, where somebody's invested money for 10 years and then they want to know what's in the fund at the end of the time. But he's investing the money today, okay? All right. Yeah, but I appreciate you stopping me if it doesn't make sense, stop me, okay? So, how much must he invest today? Who is my person, Brett? Oh, Kyle, okay. So what was our factor back here?
How do you read
Oh yeah, how do you read these tables? So go to table 4, and you're looking at...
How do you know which one's table 4?
Oh, it says 6-4 at the top.
Oh, okay.
So you're going to 8% column, and go down to number 10.
6.71008.
008, right?
Yep.
Okay. All right, so we're going to multiply that times 30,000, and we get 201,302. Okay? So now what is that saying? If he were to put in the fund 201,302, then he could withdraw 30,000 for 10 years. How much is he taking out, Jonathan?
30,000.
I mean, in total. 30,000 times 10 years. How much is he taking out? 300,000. Right? But he only put 200 in. So do you see what's happening? He's got enough, you know, that interest rate. You know, y'all don't care about retirement at this point, do you? No. Are you worried about retirement? What are you worried about? Getting a job, worried about paying the rent, whatever, right? Not retirement. But at some point, you've got to worry about retirement. And what's the deal? What if this guy lives 12 years instead of 10, right? Then what happens? He's eating rice then the last 2 years. So, I mean, this is a very real problem. How much money do you need in the bank today to take out 30,000 a year, right? It's a real important question. And what should he do then if he thinks he might live 12 years? Work a little while more, right? Put more money in the fund. If he doesn't have 200,000 saved up, you know, at this time, and he thinks he might live more than 10 years, he should keep working, okay? So my mother-in-law's 82. 82. She works full time. I don't think she had 200,000 in the bank. You know what I mean? You know? So just saying. A lot of people work, keep on working. So you got to think about retirement now in order to not be in that shape. So let me tell you about retirement. How much should you save when you get a job? How much should you put away for retirement? So Avery, when you get out of here, you want to make a lot of money, right? Because you're an accountant. You're going to be a CPA, and you want to make a lot of money. And how much of that should you save for retirement? Or should you just spend it on a boat?
That's probably what I would do, but
Yeah, because you're not going to worry about retirement. But about the time you turn, 50, you're going to say, oh, wow, what about retirement, right? So unless you want to, think about my mother-in-law, right? Think about if you want to be working at 82. So what should you save for retirement? There's a percentage that you should save for retirement. A percentage of your salary. What do you think that is? This is what, like all the financial plans, just give me a percent. What would you feel? 4 or 5? Yeah, you'd say, oh my gosh, I'm saving a lot, right? If you saved 4 or 5%. And maybe you should save for several different reasons, but for saving for retirement, to have enough money when you get older, the percentage is 15%. So that's kind of high, right? And sometimes the company that you work for might put in half of that, and then you put in the other half. So that makes it a little easier pill to swallow. But no matter, one or the other of you guys should be putting in 15% to really be able to retire. And so that's the reason I like, when we're going over these problems, I kind of like to bring this topic up. Y'all are going to forget this the minute, that first check comes. But when the first check comes, the first big check, you're going to feel absolutely filthy rich. So that's time to make up your mind, you're going to put 15% in, okay? Don't buy the boat until you get the raise, okay? Then you can get the boat and blow all the money you want on the boat. After you have, money for a house, money for life insurance, money for health insurance, money for retirement, money for a rainy day, money for a washing machine breaking down, or to buy a new car, then you can get the boat and blow it, okay? So there's like a lot of different things that have to happen before you just flat out blow the money, okay? So do you think you're going to remember that?
Hope so.
Okay, good. Yeah, because don't be working at 82. Okay. Let's see, we did number 10. Okay, so the one I want to go now is the hard problem, the bond problem, okay? Okay, so we're going to do the bond problem now. Do you think we have these present value problems, or Jonathan, do you think we should do another present value problem?
I think I got it.
Okay, all right. Okay, so if we have enough time, we'll do another one, okay? But remember, y'all have, all of these brief exercises are just excellent problems, every one of them. And you can, cheat if you want to and look at what that, don't y'all have that little number at the side that tells you where it came from, what section, 6 or 5 or whatever? Try not to look at that. But anyway, that would be, you could do that if you wanted to. All right, so now we're going into the bond problem. And also remember, maybe in this chapter, it would be a good idea to, if you're having trouble with this, listen to the videos again. Has anybody found the videos? Okay, excellent. Were you able to listen to it? Okay, so where is the link? Because I've kind of forgotten.
I just clicked on hands up, and then just the link that's in the box.
And then you just click the link and it takes you right to them, and then there's a video for virtually every day. So this is one that you could listen to them over again if you need to, or maybe if you miss class, right? So it's in Hands Up. Okay, so now we're going to do the bond problem. That is number 15. Okay, so now let's talk about bonds. I think we're going to do number 15. Maybe I'm not going to do 15. Yeah, let's do exercise 13. And I'll leave 15 there because the answer's there in the book, and then this will give you a different one to do. Exercise 13. Okay, now this one, hold on to your seatbelts because bonds are a little bit different, okay? But first we're going to talk about what bonds are. bond problems have two parts, okay? Bond problems have two parts. When you have a bond, what we want to figure out is let me explain what a bond is. A company issues a bond, and they get from these investors, the people that invest in the bonds, a principal amount. Okay? People give them money, okay? And in return for that, the company pays interest annually. Okay, so no, they pay interest annually or semi-annually. Either one or the other. Okay, so like, let's say Georgia Southwestern wants to build a new dormitory. How much does that cost? Like, how many million? $6 million. Okay, so they're building a new dorm for $6 million. That's our principal amount, right? They need somebody to give them $6 million. Okay, so in return, they issue, each person that buys part of this maybe gets a bond for $1,000 a piece or something like that. They buy them in increments of $1,000. And all these people, they have to pay them interest annually or semi-annually at a certain interest rate. So the face amount interest rate determines how much interest they're going to pay them. So now by that I mean they specify we are going to pay 10%. So annually, let's say, and 10% of that is $600,000, right? Every year they have to pay the bondholders interest, every year. Now, why is that? Because that's why people invest in bonds. Let's do the classic bond investor, an old person that's retired and wants to just get interest in every year, right? So they're paying these people off, and they're going to do that for N years, however many years. It might be a 30-year bond, a 20-year bond. Let's say it's a 30-year bond, okay? So now the thing is, this is one part of the problem. What is the principal amount? The other part of the problem is we have to figure out the interest amount, okay? Because a lot of times they don't give you the interest amount. But the main second part of the problem, let's don't call this part. The second part of the problem is they have to pay back the principal. Okay, so the end of the period, after 30 years, we're going to pay back the principal. So what are we going to pay these people? We're going to pay them $600,000 at the end of the time, and we're going to pay them we get $6 million from them, which we pay back, and we pay them $600,000 a year. So there's two parts: the principal that we pay back and the interest that we pay them every year or so. Okay, so now let's kind of work problem number 13. George Henke manufactures cycling equipment. He wants to build a new plant. He has decided to raise funds by the new plant by issuing a $200,000 11% corporate bond. It looks like 15 years, right? From 2014 to 2029, 15 years, with interest payable twice a year, okay? So that's semi-annually, okay? At the time of the issuance, the market rate for similar instruments is 10%, okay? So we're going to first calculate the present value of the amount that we're going to pay back. This is the principal amount at where we are going to look at N periods and with a certain interest rate, okay? So this is, we're paying this money back at the end of the time. What kind of problem do we have there? It's a regular present value problem. What's the present value of the money that we're going to pay back at the end of the period? Do you see that? It's a single sum. We're paying this money back at the end of the period. It's a present value of a single sum. So what table do we look at for this? Table 2, right? Okay, but now there's a little twist here before we get ahead of ourselves. And the twist is this interest rate right here, okay? Because in the problem, it told us let's just write all these things down. It's a $2 million bond. They gave us an 11% interest rate. This is by issuing a 11% bond. What does that mean? That is the face amount interest rate. Okay, what do I mean by that? Face amount, that's the amount on the bond. The bond is going to pay 11%. What do we use this for? To calculate the payment. See how I did up here? The face amount is used to calculate the interest payment. So this number is used to calculate the interest payment. All right, and then it's a 15-year bond. So is our N 15? Avery? Is our N 15? With interest payable March 1st and September 1st. So this is a semi-annual interest rate. What do we do with that? A semi-annual interest. We're paying interest twice a year. Times 2. That's why I ask you, because you're the one that does this part, right? You do the times 2 or times 4, right? So now what do I do with the interest rate? Ooh. I multiply this by 2, and what do I do with the interest rate? Anybody? Divide by 2, right? To get 5.5. Right? Remember that? Okay, good. All right, so our N is then 30. And why did we multiply that times 2? Because we're paying interest twice a year. And remember what I said? This N is the number of periods. It's not a year. No, it's not a number of years. It's number of periods. Number of periods that we pay interest, okay? All right. Now, we're not quite done. At the time of issuance, the market interest rate is 10%. What are we going to do with that? This is the market rate. Why did they tell us this? Well, they told us this because this helps bondholders decide if they want to invest in this investment. Think about this. The market rate of interest is 10%, but these guys are paying 11%. Is that good news for these people that are investing in the bonds? Anywhere else in the world, they can get 10%. This one company is paying 11%. Do they want to invest in this one company? Is that good news? Yes. So, because that's good news, would they be willing to pay more for this bond? Yes. In order to get more interest rate, okay? So what we're doing here is we're figuring out how much more they would pay. So even though this is a $2 million bond, people are going to pay more than that for it, okay? So in this case, when the market rate is greater than the face rate, then we have, what do we call that? A discount or a premium? premium because they're paying more, that's a premium. Now, if instead the market rate is less than the face amount, the face rate, what do we call that? That's the discount. Now, what would you say if the market rate equals the face amount? What do we call that? What would they pay? You got it, Avery? No? No? Nobody? More or less? The same. So what do we call the same? Par. It would be issued at par. Okay. Now, how important is this stuff right here? You should know this, okay? All right? So you should know that because that is going to help you determine how much they're going to pay for these bonds. How much are they going to pay for these bonds? It's going to be more than $2 million. Our answer is going to be more than $2 million. Okay, so we're going to use, which interest rate do we use right here? In this place right here, we're going to use the market rate. The only time we use the face interest rate is to calculate the payment, okay? So I think we can fill in all the blanks here. All right, so our principal amount is $3 million. Our N is 30, right? Yes.
3 million? Is it 2 million?
2 million. Yes, somehow my problem says 3 million, so that's going to be a problem. 2 million times 30 for the N. The interest rate is what? We're dividing this by 2, right? Okay, so the interest rate is 5%. We're going to look on table 2 because we're finding in this part of the problem, we're finding the present value of the principal. Okay, this is this part of the problem, present value of the principal. Okay, so we look on table 2 and do we, now I'm not trusting these numbers, 23138 is the number I have, yep.
Real quick, why do we use the market rate here?
Okay, because this is, people are trying to decide how much to pay for these bonds, so we need to compare that to what they could get anywhere else. They're going to pay an amount equal to the market rate. If they're going to get back $2 million at the end of the time, they're trying to decide what kind of interest rate I expect, and that's the market rate. Okay. All right, so we multiply the principal amount times this number, and we get 46,276. Is that right? Maybe with another 0. Multiply that out for me. Okay, that's right. Okay, so then now we're going to get, on the next part of this problem, we want the present value of the interest payments. This is going to be this part of the problem, right? There's 2 parts to a bond problem. The present value of the principal amount, the present value of the interest payments, okay? So in this, they're going to get interest payments twice a year, remember? They're going to get interest payments twice a year. The amount of the interest payments is 5.5. Okay, let's figure that out. This is an ordinary annuity, right? Because we're getting them at the end of the period. And the amount of the interest payments is $2 million times 11% divided by 2. Okay, so what does that work out to? 110,000? Are y'all helping me? 110? Okay. All right, so that's the rent, okay? Let's call this a different way. Present value of ordinary annuity is the rent times, this factor. And on a present value of an ordinary annuity, we look on table 4, right? So the rent is 110,000, okay? So to calculate this, remember, we use this 11% rate. That 11% rate is the face rate, the face interest rate, okay? But on this I right here, we use which one, Kyle, in the market rate, okay? All right, so we're going to look on table 4 to find the factor. And on table 4, that factor is 15.37245 maybe. Okay, so we multiply that together. This number times 110,000, what do we have? I'm going to change these numbers too. Okay, what do we have? Okay, so now the present value of the interest payments is some big number, right? So what are we going to do? We're going to add these two numbers together, this number and this number, to get the total amount that they would pay for this. So they'd pay over $2 million, right? But we already knew it was going to be over $2 million. Did I add that right? Okay. All right, how confusing was that one? On a scale of 1 to 10, this one is like a 10, right? Okay, so is there going to be one of these on the test? Yes, because we spent a lot of time on this. So, but this combines two different kind of problems, right? Really, I mean, the principal amount is going to be a present value problem, and the interest amount is going to be a present value of an ordinary annuity problem. It's really, you just need to understand the philosophy behind it, and there's really two hard parts to the problem. And Kyle's got one of the hard parts, right? Which interest rates do you use? Which interest rate do you use? And the thing is, you use the face amount interest rate to calculate the interest payment, and then you forget it. You use the market rate to put inside this factor thing. Okay, and the other part of the problem that's hard is what? I think to me, the multiplying by 2 and dividing by 2, right? This part right here.
And the reason why we did that because it was semi-annual.
Semi-annual, yeah. If it was quarterly, but usually it's semi-annual, Usually bonds are they usually pay interest semi-annually.
Okay, so pretty much if you multiply the 2 for the period, then divide everything else out.
You multiply this by 2 and divide the interest rates by 2. Yeah. So, but sometimes they're annual, sometimes they're paid annually, sometimes semi-annually, but not usually quarterly. Okay.
And annually, we just
Keep it like it is. Keep it like it is, yeah. And then another thing you need to know on bond problems is whether they're going to be issued at a discount or a premium. And now a good problem to work for that is there is a good problem to work for that. Oh yeah, exercise 7. So look at exercise 7. What amount would you pay for a $50,000 bond that matures in 15 years and pays $5,000 a year in interest? If it pays $5,000 a year in interest, what is the face interest rate? %, right? It's 10%. And then they want you to say, what would you pay if you wanted to earn a yield of 8%, 10%, or 12%? And you should be able to tell me, which one of these is going to be a premium, a discount, or a par, right? Okay? And then you could work those out. See, that would be 3 problems that you could work out and do a discount, a par, and a premium. And that would be a lot of practice on a bond problem. But this one, does it pay interest annually or semi-annually? Angela, do you know? Yeah, it looks like annually. It says $5,000 a year in interest, so that's an annual problem. You wouldn't have to fool with the ×2 part on that one, see. But there's a bond problem. There's several other bond problems, okay? All right, so I think we are done then with chapter 6. And remember, you have homework due.